Hi YouTube, this is Joe Calton with Calton Cutlery. You can find us on the web, caltoncutlery.com. So I shot a video yesterday on using a toaster for tempering knives, and I don't think I got everything as clear as what I wanted, or put everything in there as what I wanted. So I'm going to shoot it again. Also, I'm trying the camera with the autofocus shut off. And that new mic, it is extremely sensitive. Yesterday I had the oven running while I was shooting the video, and it was picking up the fan cycling inside the oven. So maybe this one will be a little bit clearer. Okay, so we're knife makers. We need to temper our blades after we harden them, whether you use a kiln, a forge, a torch, whatever it is that you use to harden your blades. Now you need to be able to temper those blades, which tempering is heating the knife back up to a lower temperature to be able to soften the blade a little bit, take some of that brittleness out, and to be able to get a good, tough, serviceable edge. Generally speaking, with we're just going to use 440C today. With 440C, you're looking at somewhere between the 300 to maybe 600 or 700 degree range, depends on what you want to do with that steel. Now, for a knife, what we want is the maximum working hardness that we can get. Okay, so we want to get that steel as hard as we possibly can in the quench, and then we want to draw back just enough of that hardness to where the edge is stable. All right. That is called the maximum working hardness. You find that through doing edge deformation tests, which is the brass rod test, only you push it farther until you push the edge to failure. Note how that edge fails, decide how you want it to fail, and then adjust your tempering temperature to adjust the point of failure in that blade. So if you want the blade to be a little bit chippy, you a lower tempering temperature. You want the blade to be a little bit softer so that the edge deforms rather than chips, then you would raise your tempering temperature. Okay, so that's what we're after when we're tempering a knife blade. I like using toasters for tempering. They're very controllable if you set them up right. They don't produce a lot of heat or a lot of very intense heat like what a heat treat oven will do, like my big 220 heat treat oven. Big coils, the second they fire, they put off an awful lot of heat. I'd much rather put temper a knife in a toaster where it's got much smaller heating elements, and will give you a much gentler fire each time, and then just a nice easy ramp up to temperature, hold that temperature for a while, and then cut it off. The problem with toasters, you've got several of them. Okay, so your toaster oven, generally speaking, doesn't have the amount or the quality of insulation that a heat treat oven or a kitchen oven would have. The controls aren't as precise, both in the repeatability of the controls. So let's say you turn this right here is the temperature setting on this toaster. If you turn it off and then you turn it to 300, and then you turn it off and then you turn it to 300 again, sometimes they won't return back to that same setting. There's slack in the knob. That's a big problem. Also, if you set it on 300, is the oven actually coming to 300 degrees? Or is it going to 350, or is it going to 250? So there's that, and then also the cycling of the toaster. So if you set it at 300 degrees, it's probably not going to come up to 300 degrees right off the bat and then hold 300 degrees. More than likely you're going to have a temperature swing where you set it at 300 and it'll swing from 275 to 325. Okay, so those are your big problems to work around with using a toaster as a tempering oven. Now, you can get oven thermometers, and that will help out an awful lot. but it still won't calibrate that toaster the way that it should be to the steel that you're using. You can grab laser thermometers, you know, all that kind of stuff. But honestly, the easiest way to set a toaster up to use as a tempering oven for a particular knife steel is to use the steel itself as a means of calibrating the oven. Okay, so okay, another thing on your oven thermometers first. You know, these are the oven thermometers that I use. You know, I went to Menards the other day and grabbed, oh, we're going to try the manual focus on this. So I went to Menards the other day because I needed some how's that look? Just a regular old $5 oven thermometer from 100 degrees to 600 degrees. And I'll get it back up to, there we go. You can, these are about $5 a piece. You can grab 2 of these off the same rack at the store, bring them home, stick them in an oven, put them right next to each other in an oven that you think is about 300 degrees, and those thermometers can read, I've seen as much as 30 degrees difference from each other. So how do we take the inconsistencies in our thermometers, the inconsistency of the temperature dial, the inconsistencies of the toaster cycling around its set point, and the inconsistency of the temperature knob, and bring all of that in to where we do what we need to do, which is provide a consistent and reliable and accurate temperature to temper our knife. The easiest way that I know to do that is to use the knife as a calibration instrument to set your toaster up. So here pretty soon I've got another toaster that should be here today that I'm going to use for 440C and heating up kydex and leather sheaths and all that kind of stuff. It's a digital one because I'll be moving the set point, you know, around for different projects. This one right here is going to go for 5160. But we're going to use 440C as an example. Okay, so let's say when I go to set that other toaster up, I want to set it up for 440C. I will take one piece of 440C. That way I know it's the same steel over the course of 4 or 5 or 10 knives that we're going to make. Go ahead and make, I don't know, 5 knives right off the bat. Okay. Get them profiled. I wouldn't worry about drilling holes. These are just test blades. You're going to throw them away when you're done anyway. Profile the blades, get them into the heat treat oven, quench them, make them hard. Now go ahead and grind all 5 of them as close as you can to each other. So take measurements several different places on the blades, on each blade, and get them all as close as you can. Now 440C, my last toaster, I had it set on 300 degrees, and that was the setting for 440C. So go ahead and take one of those knives, stick it in the toaster with your oven thermometers. Let me back up a second. So once you have your oven thermometers, you mark those oven thermometers and then place them inside the toaster, and then mark the oven thermometers as to what position they stay in inside the toaster. So in this oven I've got 3 of them. It's a fairly large oven. So I've got one that says L for left, one that says M for middle, and then one that says R for right. Those thermometers will never change position. They will never leave this toaster. That's very important, because that's how you get around if one thermometer reads 30 degrees higher than another one. As long as they all stay the same in the same position, then you know what temperature to bring the oven to. Alright, so you'll go ahead and you'll make that knife, set your oven at say 200 degrees. Check your thermometers and see if they're kind of agreeing with that setting of 200 degrees. My 52-100 and 1095 toaster, the thermometer setting is at 450 degrees, yet the oven thermometers, the top one reads 350 and the bottom one reads 385 while it's running. So either the temperature setting knob is way off or the thermometers are way off, but it really doesn't matter because the knives that I pull out of that oven after a tempering cycle, the edges deform the way I want them to. So anyway, so we have our thermometers. Go ahead and set it at say 200 degrees and then see if your temperature comes up and your temperature gauges agree with that 200 degree setting. If it doesn't, adjust the knob until your temperature gauges read roughly 200 degrees. Now take that first test knife, put it on a rack. I use these little racks right here. You can put the knives inside the different places. That way they hold them up to where you get good air circulation around them. Put that knife in the toaster, run it for 2 hours. Pull the knife out, let it cool for an hour, put it back in, let it run for another 2 hours. Now go ahead and sharpen that knife up and test the edge over a brass rod. See if it flexes and returns to true. Then, if it does, go ahead and push harder on that brass rod until the edge fails. With 440C and at 200 degrees, more than likely it's going to chip out. Okay? Now go ahead and adjust your temperature knob to where you get another 10 to 15 degrees higher on your thermometers. Put the knife back in for another 2 hours. Pull it out, check it over the brass rod, deform the edge, see if it's still chipping out. You keep doing that and keep going up in 10 to 15 degree increments until that edge no longer chips or until the edge fails the way you want it to fail. You might want an edge that chips out, that very slightly chips out, or you might want an edge that's going to deform a little bit easier. If you're making a knife for use in very cold environments, you might want to temper that just a little bit on the hotter side to where it deforms in a nice warm 70-degree shop, because when you take that knife out and you're working in 0 degree weather, that knife, that temperature is going to make the edge a little bit chippier. So anyway, so you keep adjusting your dial up in 10 degree increments according to the thermometers, in 10 to 15 degree increments until the edge fails the way you want it to fail. Once it does, write down the measurements or the readings on your thermometers, and then also the temperature setting. Okay, so when I get this one all set up for 5160, whatever these thermometers read, they will get written down on the toaster or on a stick-em note, up on the shelf, along with the setting. That way you can repeat. If you ever change that oven to something else, your thermometers, as long as they're staying in the same place and the same thermometers, will allow you to come back to that temperature. Okay, so you have your test knife, your first test knife, and you've got the edge failing the way you want it to fail. But you might have run 10 2-hour cycles on that blade, easing it up until you get, the temper that you want. Well, unless you're going to temper all your knives out of that steel from that time forth in that same pattern, 10 tempers increasing 10 degrees each time, you're going to want to double check and make sure that your normal temper cycle is going to agree with that setting. So for 440C, I like the classic 2 hours at temper, 1 hour cool, and then 2 hours again at the same tempering temperature. So you'll take your second test blade, go ahead, put it in at the last setting for 2 hours on, an hour off, 2 hours back on, then pull it out, sharpen it up, and then test the edge. If it's still where it needs to be, hey, great, you're golden, run with it. If it doesn't, then you'll need to adjust your temperature settings again, find the right tempering temper for that second knife, and then repeat the test on a third knife, so that that a 2 hour or classic 2x2 tempering cycle at this particular set of temperatures on that knife will produce an edge that fails this way. Once you have that done, then repeat the test a fourth time just to double check, make sure everything is really the way that you want it. And then from that point on, you can go ahead, just put the oven to those temperatures. Which honestly, once I have an oven set like this, because it takes quite a bit of work to get an oven dialed in to the steel that you're using. Once I have that oven set, it stays there. I never adjust that knob. I will make a mark, on on your, where the numbers are on your knob there. I'll make a mark there so that if it ever does get bumped, or let's say somebody else comes into the shop and they don't, they're not used to working with you, and they move that knob for some reason, that it'll get you back into the ballpark. But yeah, so once I get a toaster set, I leave it like that all the time. So anyway, so by doing that, you're using the steel to calibrate the oven. And really, when it boils down to it, you can, talk about Rockwell numbers, you can talk about absolute temperatures, two guys swapping heat treat information. Well, they've got different toasters, Rockwell hardness testers, they can get out of calibration, apparently there's a fine art to using those things. But really, when it comes down to the end of the day, the performance of the steel is the only thing that really matters. So why not use the performance of the steel to calibrate your equipment? Another couple of tips on that is, if you're trying to do this, when you're trying to set your toaster up, use steel from the same bar. There can be a lot of inconsistencies between, let's say you order up 10 36-inch long, 1/8 inch thick by 2-inch wide bars. Well, you never know if all those bars are from the same lot, or if two of them are from the last lot that the steel supplier got and the rest of them are from the new lot. Personally, I like to buy my steel in as large of a piece as I possibly can. So the other day I made a new steel order for 440C and 1095, and I bought a full sheet of 440C. 16th inch thick, 2 foot wide, 6 foot tall. It was cut into two pieces just to make it easier on the UPS guy, but that's about the smallest I'd really like to order steel, and even that was, I think it was probably $700 by the time shipping was all said and done. And that is an awful lot of steel, but I can go ahead and set my toaster, double check the heat treat with a new piece of steel, and then I know that this corner of that piece of steel and this corner of that piece of steel are probably fairly close to being the same. So we went over the thermometers, the fact that thermometers can be inconsistent, which is why that you mark them in the position that they're going to stay. Your temperature setting, how not to trust your temperature setting, trust your thermometers. Your cycling, okay, so when you turn this oven to 300 degrees, and it might go to 325 and 275 over the course of your 2-hour tempers, calibrating it with the steel takes all that into account. So if you temper a knife in here at 300 degrees, and for in the first hour it was at 250, and the second hour is at 315, when you pull that knife out and you do your edge deformation test, that edge is going to tell you pretty much what the average temperature was. Always listen to your steel and your edge. I mean, it'll tell you what it needs if you listen to it. So I'd trust the steel way more than I would trust the temperature readings or the temperature knob. It can cycle up and down, but as long as you're calibrating your oven to your steel, then all that gets taken into account and you should have good results. One last thing is the timer cycles. Let me check, see how much time I have. Don't have enough time for the timer cycle, so we'll end up having to do that another time. I hope you enjoyed the video, and we'll see you next time.